Hello, and welcome to episode 204 of Daryl Show Your Work. In this episode, I'm going to be conducting some manual analysis of an AI bot's chatbot source code to try to find some vulnerabilities in it. All right, but before I get started, if you want to learn how to do some excellent AI related things like this or anything cybersecurity related, please take advantage of the last day of INE's 3-day flash sale. All right. So they have right now they're running a special on 30% off of all their certification vouchers except for the ICCA voucher, which that is the cloud computing voucher. $200 off in their INE premium access to all of their complete learning library. That's red teaming, blue teaming, everything, or $100 off of just their fundamentals library. So those are just all the junior level learning paths and certifications. All right. So if you want to learn where to go, how to apply these savings, all right. If you look in the show notes below, I have the link there, which is get.ine.com/Daryl, and also the related promo codes to get those discounts on the premium access and also the fundamentals access. All right, and you will not be disappointed with the savings and with the in high demand skills that you'll receive upon your purchase. All right, so to get started here, what I'm going to be doing is I'm going to be mapping out the components and the architecture of a llama based chatbot. So I'm going to be doing a security focused architecture review, and it's going to be that of the type of chatbot it is. It's going to be a healthcare related chatbot called medassist AI. So this is just going to include mapping out every component, tracing how data flows, inspecting what's stored, and identifying any found exposures of sensitive data. So in order to do this, I'll have full access to the running application along with its source code, logs, and support services. So this is typically done before the rollout of an AI chatbot to production. And needless to say, it's highly important since this LLM it deals with PHI. All right, so to access it, I'm going to navigate to where it's being hosted, and that is HTTP. Oops, hold on, let me fix that. Too many T's. Localhost. All right, and then that's being hosted over port 8080. All right, and this is going to bring me to where that's being hosted. All right, so we can see it threw me right into the chat bot here. So the Med Assist AI is saying, "Hello, I'm Med Assist AI, your employee benefits assistant. I can help you with health insurance, dental, vision, 401k, parental leave, PTO, and more. What would you like me to, what would you like to know?" All right, so right now, I'm just interested in just testing out and just wanting to view the actual chat bot, the front end, myself. So I'm going to just put in the test prompt here. I'm gonna say, "Good afternoon. What information can you provide about me?" Just to see what it comes back with. All right, and a somewhat long response. It basically tells me my internal healthcare benefits. It's my internal healthcare benefits assistance, and it can provide me with general information. However, they don't have access to any personal information, including my name or employee ID. But they can tell me that if I do that, it'll that it'll give me any of the information that it spoke of before. All right, so the first thing that I noticed, I'm going to highlight this part right here at the bottom. All right. All right, so the first thing that I'm noting here is that under the AI response here, what I've highlighted, that we can see the actual file names that it's using as data sources. So the AI uses something known as RAG to fetch this information. So RAG is actually short for Retrieval Augmented Generation, which enables an AI model to fetch information that it wasn't originally trained on from an external source. So these data sources, they should not be exposed. So if I'm a malicious user, these are definite details to note as part of an passive reconnaissance campaign. All right. So moving on here, now I'm going to identify and define services in the Docker Composer file. All right, and what a Docker Compose file that allows developers to configure all their application services, networks, and volumes into a single file, which can be started with a single command. All right, so in order to access this, I'm going to have to jump back out here to the desktop. All right. And then I'm going to right click this. This is the Docker Compose file, and it's written in YAML. And then let's open that up with Mousepad. All right. So I'm gonna start from the top here. All right. So right now I want to go through each service and just analyze the variables in each service. So the first service that I'm going to be looking at here is the medassist-app service. All right. And so this is probably the user interface that I was interacting with. All right, now if I go down here to build, so this build line is referencing the folder that contains the build information. And I could go back here. All right, and I'm talking about this folder right here. This, all right. So it's referring to that. So it also tells me that it's being hosted on port 8080, which we already knew when I first accessed it over my browser. All right. So going here to the next section of the variable under the Medassist app. All right, is this is in the environment variable, which tells me that the AI model being used is Olama, but it doesn't provide the version. It also appears to be running locally on port 11434, and I can verify this. So let's open up a terminal here. Just go to applications. All right, I'm gonna expand this, and I'm going to use the netstat tool to basically to view all open ports and see what is running, to see if I could find that port and what's running on that port. This may take me a few times. For some reason, it doesn't work. Okay, no, it worked. It worked the first time this time. All right, great. So this right here, this is the port. Hold on, highlighted too much. Here we go. So this is the port. All right, we can see this is port. Um, since it's being hosted locally. All right, so you notice that we see other IP addresses, but we don't see an IP address here because it's being hosted locally. So we can see that it's being hosted locally on port 11434, as it said in the Docker Compose file, and it is indeed hosting an instance of Olama. All right. And then that also tells us, since we don't have a remote IP address here, that is actually running outside of a Docker container. All right. So let's jump back into here. All right. So also if I look where it says Chroma host, this is and I'm talking about this line right here. All right. All right, so Chroma host, This is actually a vector database that's being hosted on port 8000. So this verifies the use of RAG. And when an AI model uses RAG, it uses it to access external sources, and it breaks them down into chunks and saves them into a vector database. All right. So going to the next line here to Elastic Search. So Elastic Search, this is being used to store logs and is being hosted on port 5200. I mean, excuse me, 9200. I'm sorry. So it's another, both service databases, just a Chroma host. It saves the prompt information in as chunks and vectors within that and within the database, which it retrieves, and then also the Elasticsearch, it serves as a database that stores logs. Now, logs of what? I'm gonna get into that. All right, so next depends on. All right, so this informs me of excuse me of the chat box dependencies. So I can see that that medassist can run both Chroma DB and Elasticsearch. In order for that, they can run both of these, but in order for it to start, both of these services actually has to start before it can run. All right, and then extra host. All right, this just refers to where we saw Olama being hosted locally. All right, so this is just referring to that. All right. And let me see. Going further down. All right. The next thing is I'm moving on to another service. So those are all the variables for medassist-app. Now, for the next service is the actual Chroma DB service. So again, this tells me that Chroma DB is the vector database in use and that it's running on port 8000, as we saw above. However, I'm not seeing any security or authentication setting are present. All right, so that's one thing that we need to remember. All right, and then under that, the variable under that, all right, under the ports variable is it's the volumes. All right, so this is telling me that the data in this database is non-volatile and persist across the Docker container restart. All right, so that means that as many times as that Docker container is restarted, that the data within that is persistent, which we want persistent log data, in our Docker container, which of course is hosting uh, our um, our our LLM. Okay, so the um the next highlighting this here. All right, so the next service that I'm going to be going over here is Elasticsearch, and the primary area that I want to focus on here is this area right here, this variable. All right, and that's the XPack security enable equals false line. All right, so this tells me that the security is actually disabled for Elasticsearch. All right, and again, this is where the logs are being stored. So that's not good. So that tells me that potentially there's no authentication of measure in place. And again, that it's being hosted on port 9200. And then we can see the presence of another volume, meaning that the logs are being that's being stored are persistent. And I'm sorry, when I meant up here, I meant that that the chunks and the vectors in the Chroma app are persistent, along with down here that the logs are persistent. So we want both of those elements to be persistent, because that's how we get consistent answers, and we know we have a history of what is being queried or passed on the back end. All right. So moving down to Kibana. All right, this is another service. So actually, Kibana is the user interface and data visualization tool for Elasticsearch. So, and also when we actually access Elasticsearch, or they interact with it, we actually are going through Kibana. So appropriately, the environment variable references Elasticsearch, and where it's being hosted. All right. So that's this, and we can see again, once again, that Elasticsearch is being hosted on port 9200. All right. But it also appears that Kibana is being hosted on a separate port, and which is the standard port that Kibana is hosted on, which is 5601. All right, then lastly, the last service that I'm taking a look at here is the C data service. All right, and this is what actually populates the Chroma DB vector database as well as the logs and Elasticsearch. So we can see that it references the OLAMA as its environment variable. Okay, right here. All right, along with its port, and that it has a dependency on Chroma DB and Elasticsearch. So we see depends on, and then we can see that here. All right. So the next thing that I want to do is that I want to now we've seen that that Elasticsearch, I mentioned that it was missing any sort of reference or any sort of authentication. All right, so I want to verify that lack of authentication. So what I'm going to do is I'm not going to go directly into Elasticsearch itself, but I'm going to go through Kibana. All right, because remember that's the actual user interface in order to view the things that are actually the logs that are actually being stored by Elasticsearch. All right, so going back to my browser, I'm going to open up another instance, and I'm going to say HTTP. All right, we're still on the same system, says localhost, but this time I'm going to navigate to, we said that Kibana is 5601. All right, so let's go there. All right, we can see that it's loading Elastic, and I click explore my own. And yeah, as insinuated, there was no authentication measure. All right, so that means that any employee that knows that this port number or that's familiar with this Kibana port number can access the Elasticsearch logs, which we don't want. All right, so that's one vulnerability found right there. All right, so the next thing to be able to see if I can find other vulnerabilities, I'm actually going to access and analyze the Medassist chat box source code. All right, so let's go back to my folders, and if I go to Medassist-app, the folder, let's look at the Docker file. I'm gonna say open with Mousepad. All right, and there's not really a whole lot to see here. The only interesting thing here is that, which we already know, is that the exposed port is 8080 because that's what it's being hosted on. So not too much interesting there. So, but if I go to the main.py, which is the Python file, this is the actual source code. All right. So, being under the configuration setting here, all right. All right, so the first three lines, all right, let me highlight those. All right, so the first three lines, we can see the methods for accessing the get methods for accessing the information that I already gathered are from the Docker Compose file, which is the model information, the vector database information, and the Elasticsearch information. However, on this fourth and fifth line here, there's some very interesting information. It's something that we need to stay aware of throughout this video. All right, and we can see that the fourth line has clear text credentials for the Postgre SQL database, as well as an internal API key on the fifth line, which is also used, to authenticate. So this in itself, it's not uncommon to see present in the source code, but we're gonna see later on why this is problematic and how, when combined with several other elements and several other vulnerabilities, that this becomes very problematic. All right, so moving down to the system prompt. All right, and I'm highlight all of this. All right, so the AI system prompt is set for hidden. What it is a set of hidden hard coded instructions given to an AI model before it interacts with any user inputs. So it dictates the AI's persona, tone, scope of knowledge, and provides some guardrails, some parameters that it has to stay within. All right. In this instance, it tells the AI that is what its job is, who it works for, and the scope of questions it can answer, and what things it cannot reveal. The big problem here is that sensitive information, such as the API key, is contained in the system prompt. All right, we can see that right here. All right, so on this line right here, where it says admin access, all right, we can see that API key there. And then and also said it's also telling us here on under in the area of what things not to reveal, what employees have access to sensitive information. So again, if I'm an attacker and I'm conducting recon, and I think I showed this in a previous video where I was conducting some passive recon, that this is how we have that logical deduction to determine, okay, who can get us what information, who to target for what information. All right, so we don't want them knowing. We don't want them knowing that a um, um, manager level queries can access salary band information data. Great. Now I'm going to go look for managers. All right. Or what the benefits team's extension is. Now I know who to call the social engineer. I would say honestly, the only viable part of these instructions are to never reveal an employee's social security number, because but you can confirm benefit eligibility. All right, so that's a certain PII that we don't want leaked out, and that's actually something that should be captured here as far as what not to reveal to users. All right, and then lastly, all right, I wanted to highlight this part right here. All right. We can see the Chroma DB collection name, and that all the source documents that we saw early in the very beginning are saved to that fall under. All right, and they fall under HR documents. So if you need a refresher of what I'm referring to, if we go back here. Remember these guys right here, these documents, all three of these documents can be found under HR. Let me go back here under HR documents. All right. So let me do something here. I'm gonna turn on line numbers so it's easier for me to navigate. All right. So I'm gonna scroll down here a bit. All right. So here on line 135. All right. So and this is under the section LLM interaction. All right, we can now finally see what the actual Olama model version is. So it's Llama 3.1 8 billion, the 8 billion parameter variant. All right, we can also see the full prompt is being passed. All right, and that's right here. That's where the full prompt is being passed. So that's including the system prompt, the user prompt, the full prompt. All of that is being passed, and then we can also see other settings such as the temperature. All right, and that's right here. All right, and then so to give a brief overview of what the temperature is, an AI model's temperature controls how creative the model can be when responding to queries. The higher the temperature is set to, however, the higher the chances of there being hallucinations, which think of it as like a wrong answer, or going out of scope of what is being asked for. So this point four setting is actually good, since the model is supposed to provide more formal answers in a professional setting. So keeping it low like that is going to keep its responses more professional and less likely to hallucinate. All right, so going down, scroll down a bit. Well, actually, hold on. I would actually want to go up. All right, so here under the logging section, I'm up here. All right. So if we go to line right here, line 56, just wanted to show this. So we can see that every chat interaction has a timestamp appended to it. So this is where the timestamp is being appended to each chat interaction. All right, and then going down here to line 67, RAG pipeline. All right, and let me see. In the first line here, all right, where we say def get chroma client, all right, we can see that the get method used to retrieve information from the chroma db vector database, but I still, like, similar to what we saw with elastic, I don't see any authentication information present. All right, so in line 83 right here that I have highlighted, all right, we can see the embedding model in use, which is nomic embed dash text. So what a RAG embedding model is, it's the AI component that translates the human language into machine readable lists of numbers or vectors. All right, so that's the part of the whole vector database that converts that human language into chunks and then vectors. All right, and then let's see, going down a bit more. Let's see, where is it? Oh, right here. Okay. So I'm right here, API endpoints. All right. So if I go down a little bit to line 160, all right, we can see that the API endpoint is the slash chat. All right. We can see that this that it was it looks like that it was more than likely that this is more than likely what I was using to actually chat with the chat bot. All right, because we can see all type of chat references here, so more than likely this is what was being used. This endpoint is what was being used to interact with that chat bot. So we can also see I'm gonna highlight these here. We see steps 1, 2, and 3. All right, we can see the steps it takes here to work. So step 1, it retrieves the stored chunks. 2, it queries the backend LMM. All right, and then 3, it logs the parameters. So zeroing in on lines 172 through 184. All right, let me scroll up a little bit here. So that's clearly displayed. All right, so this is showing all the parameters which are logged by Elasticsearch. So we can see that the system prompt, all right, if we look at the what's this the fourth line here, all right, we can see that the system prompt which actually includes, remember it includes the API key and that PostgreSQL connection credential, all right, that that prompt is is logged into the Elasticsearch with all the user prompts. All right, and I'm specifically talking about right here. All right, so this is where we can see that now that this the system prompt is being logged into the Elasticsearch database along with the API key and the Postgre database SQL database credentials. All right, and it's doing that every time that an interaction is happening. All right, so this needs to actually be corrected so no hard-coded credentials can be logged. Also on line 146 right here, all right, where we see retrieve chunks. All right, so so basically what's happening what's happening here is that the retrieved chunks, they contain the full text of the RAG document chunks, which poses a risk of exposing PII. All right, so that needs to be corrected as well. So those are few vulnerabilities that we found here. But I want to check these last two API endpoints. Let me scroll up a little bit so everybody can see. I went too far. All right, so these two endpoints right here, um this slash health, and then we have a slash config debug. I want to see if any authentication is present for these. All right, so these basically serve as directories as well. So I'm going to use curl to test that. It's to see if there's any authentication. So I'm gonna test this from the command line using curl. All right. So first I'm gonna test the slash health API. So I'm gonna say curl and then HTTP, just like if we were doing it from the browser localhost. All right. And then we want to say 8080 because that's where the chatbot is being hosted. And then we want to be able to see if we get an authentication request for the health API. So let's see what happens. All right, so it looks like it lacks the authentication, but it doesn't really need it since it just returns the status of medassist AI chat box. All right, so it's just telling us the current state of it, which is saying it's healthy. So no real harm there. But let's check this other one here. All right, this config debug. All right, so going back in my history, I'm going to change this to config, and then debug. And let's see what happens there. And a lot of not so good things happen here. All right, so let me just highlight this. All right, so basically the problem here is that it returns a lot of information that regular users shouldn't see. All right, so it returns the chroma db host url, so that way it could tell like a regular employee where to go to access the chroma db vector database. And it has the elastic search host url, again telling folks where they want to go, try to go directly to where Elasticsearch database is being hosted. They can go there and bypass the front end interface that it has with I'm drawing a blank on the name, the Cabana. All right, and then it also has those post grade SQL database credentials. All right, so then they know how to log into that, and then it has that API key, and then it has the AI model version, and then it has the Chroma DB collection name, that HR documents. So it's just providing just a ton of information here. And it basically allows me to enumerate like a lot of the back end information that if I wanted to try to poison this AI model, is giving me the basis to do it, because it's giving me access to the back end prompts that are saved. It's giving me access to the logs, all right, that are saved. It's giving me access to the PostgreSQL database. It's giving me access to everything here. All right, so if let me jump back into the source code here. All right, and so basically we can see all that right here. All right, with this we can see everything that is passed, and it passed everything that I just said, as far as the chroma, as far as the API key, as far as the database key, et cetera, model number, the collection name. All right, so we can see all that present here, and it's basically the information is hard coded to be displayed. So this needs to be corrected so the information is not viewable to normal users. All right, and so this is just an example of how vulnerabilities can be found through some manual analysis of the back end of a AI model, of a LLM. All right, and this is something that you want to do before rolling it out publicly. All right, or in this case, even if we're talking privately within an organization, you still want to be able to find these sort of errors so you don't have any sort of insider threat going on. So please like, share, and subscribe. Most importantly, show your work, and remember to take full advantage of the last day of INE's 3-day flash sale. You won't be disappointed. And until next time, take care of yourself and God bless.